Our next presenter, Adjoa Sakwa, coming from Community College of Denver, studying chemical engineering. She's hoping to transfer to a 4-year university to finish her bachelor's degree in chemical engineering.
So to start, I would like to thank Marina Vance for letting me work in her lab, as well as my mentors and the research program team for allowing me to be part of this program, as well as the other Rex interns for being very supportive this summer. So my project is on indoor air quality and characterizing emissions of volatile particulate matter from cooking oils. So next slide. So to start, basically the project was to characterize the particulate matter from cooking oils, as I just said. It's an introduction to understanding aerosols and how particulate matter may affect human health from common household products, and how they can negatively affect climate change. They can negatively affect climate, human health, and based on their size and chemical composition. So what is particulate matter? Next slide. Particulate matter can travel in aerosols, and they can be in liquids or solids. They can come from certain activities, from, as you'll see, cooking, household products and stuff like that. They can be as small as, say, dust, pollen, dirt, and they can get as large as, like, say, fine sand and stuff like that. Next slide. So they have particulate matter depending on their chemical composition and like their sizes. The smaller they are, the more dangerous they can be, because they can travel into the lungs, bloodstream, etc. And exposure to them can cause short-term effects like cold-like symptoms like sneezing, coughing, and runny nose, and then long-term effects like cardiovascular disease and asthma. And the environmental effects could include like haze or acid rain, and as well as erosion of certain materials and rocks and stuff. Next slide. And this is like a closer look at how they can look like. And since they're very small, we need certain instruments to study them. So for this lab, basically, we took different types of oils, canola, vegetable, peanut, and the lard animal fat. And we heated it up on a frying pan. If you look at the top right corner of the photo over there. And we, as we heated it in the frying pan with the fumid, the oils were evaporating into the air. And this little device in the left corner, bottom left corner, is a thermodenuter. And what it does is, it, as the aerosols evaporate into the air, it takes it in and then it heats up the aerosols and separates them based on their sizes, and then transfer it to the to this other these other machines that we will talk about in the next slide. In the bottom right corner, there is the frying pan and then the thermocouple, which is a measuring, it's like a, sorry, it's a, it's a temperature regulating device, and it helps regulate the temperature of the oil. Next slide. So after the oil, the aerosols are pass through the thermodenuter, they go to these two devices at the bottom right corner. We have here on the left the SMPS, and then on the right corner the APS. The SMPS is scanning mobility particle sizer, and the APS is aerodynamic particle sizer. And their job is to basically count, collect, and measure the particles, and then as well as take up the volume of how much space they take up. Next slide. And so the results that we got from this project can help from regular kitchens to a large industrial kitchens. And as well as I mentioned before, like in future projects, it can help with the climate. So what we got so far was that as the oils reached 75 degrees Celsius, as you can see in as the thermodenuter reached 75 degrees Celsius, the oils evaporated into the air and almost disintegrated. Well, they pretty much disintegrated. So on the x-axis, you can see the thermodenuter temperatures being set to from 0 to 21 degrees Celsius to 150 degrees Celsius. And so 150 degrees Celsius and up was to emulate how regular industrial kitchen, like deep frying temperatures. And on the y-axis is dV log, and it was that's the concentration of how much how much space the aerosols took up. And if you look at the second graph, the red line is basically the same as the graph above, but more comprised. And you can see that this is for canola oil. And you can see that there was also black and brown carbon emitted from the oil at the same time. And so I was thinking that this could be due to the fact that since oil, their chemical composition has a lot of carbon, so probably that's also where it came from. As well as
7 minutes, Adjoa.
Okay. Next slide. And if you look at these graphs, this graph is basically showing how as the thermodenuter got hotter, the aerosols, their diameter got smaller. So as it heated, they evaporated more and more. And so the x-axis, dP and m, is that's the diameter of the aerosol particles. And then the dV log, the y-axis, was how much concentration the aerosols took up. And so the red was was when the TD was off. So it's showing as the graphs go smaller and smaller is the increase in temperature. Next slide. And so what's next is they're probably going to study more about the black and brown carbon that coexist with the oil as it was evaporated, and as well as the effects of what they can do to human health and the environment. So far, we know that black and brown carbon coexist together, and they're due to combustion from certain household activities and other activities as well. Black carbon is classified as particulate matter 2.5 micrometers, which is like pretty small. And so it can affect like the lungs, the brain, and then it can affect heart disease, as well as the environment when it evaporates into the air. It can increase climate change and as well as melting of ice caps and stuff. Next slide. Next slide. Any questions?
Okay, thank you so much, Adjoa. What other processes in a kitchen might contribute to air particles? For example, like chopping stuff up.
So like from like the stove, that can also the heat from it can also contribute to like air particles. So that's from my research, that's what I found out like online.
Okay. And Lucas, real quick question.
Hey, as far as the health effects of these particulates, were you looking at concentrations associated with people being indoors, or were you assuming that this was going out into the atmosphere and messing people up out there? Thank you.
Thanks for the question. So it was more of like, so to start, it's for indoors, and then later on, it's to understand how it could affect people outside, well, with the environment and stuff. So it ties in together. That answers. Yeah.
Okay, great. Thank you so much. We're going to go ahead and move on to our next presenter.